Hello, good morning student. How are you? I hope you all are happy, healthy and very fine at home. So, what did we discuss yesterday? We discussed about protection and deprotection of carboxylic group. For protection of carboxylic group, what are the group used to protect carboxylic group? That we have discussed yesterday. Number one, that is a carboxylic group is mainly converted into ester. When we converting that carboxylic group into ester, the reactivity of that group means ester, or the activity of that ester group as compared to acid becomes as a less, because in carboxylic group the proton which is present adjacent to the oxygen atom is highly acidic in nature. It makes the problem while carrying out the reaction of base catalyzed reaction, because this problem raised due to acidic proton. And therefore, yesterday we have learned some of the protecting group which can use to protect the carboxylic group. Number one, I think we have seen methanol in presence of catalytic amount of acid, ethanol, then what we can call it as a phenol or allyl alcohol, or the isobutylene. So these are the some of the group which can be used to protect the carboxylic group, and these groups are introduced under acidic condition and they are easily removed under acidic condition. Means here introduction of that protecting group in acidic condition as well as deprotection of that group under the acidic condition that we have seen yesterday. And today we are going to learn the next point, that is the second point, that is the Dcci, that is the protection and deprotection of carboxylic group COH. Here Dcci, what does it mean? Dcci, what will be the full form of that Dcci, or sometime it is referred as Dcci. Dcci only are Dcci, and Dcci means what? Or Dcci, one and the same thing, but in our syllabus is given as a Dcci. Means what is the full form of Dcci? The full form of that Dcci is a dicyclohexyl carbodiimide. So that is the full form of that N-dicyclohexyl carbodiamide. So N-dimethyl cyclohexyl carbodiamide, it is an oxidizing reagent and it is used for the protection of the carboxylic group. When it is used for the protection of the carboxylic group, the reactivity or the activity of that acidic group is decreased due to that one. And now this is oxidizing reagent. how it get oxidized during the reaction, that we are going to learn. Here let us take down the what will be the structure. First one, look at the structure. It is used as a protection of the carboxylic group NN dicyclohexyl carbamide, and the structure of NN, the structure is look at here, cyclohexyl carbodiamide. Di means 2, cyclohexyl, and as we know that the structure of cyclohexane means this one here, and then attach the nitrogen, double bond C, double bond again N, and then attach another cyclohexyl group. So this is the structure of Dcc or NN dicyclohexyl carbamide. So this is a structure, this is known as a Dcc. There are 2 nitrogen atom, and carbo means this one, NN means this NN dicyclohexyl. These are the 2 dicyclohexyl rings are there, and carbo means this middle carbon atom, and diamide means there are the 2 nitrogen atoms are there. So in this way you can remember the structure of this one. Now let us how it is used for the protection of the carboxylic group. Let us see here. First example, as we know that the general formula of acid is RC double bond OH, that will be treated with Dcc in presence of HO, then this one, that is a benzyl alcohol, and the product formed will be RC double bond O, then this CH2 and pH. This is a protecting group of carboxylic group. This group is a very bulky group. Due to the steric hindrance, the activity or the reactivity of that ester group becomes as a less, and therefore this is a protecting group used for this. And now for the deprotection, we can use here it can be removed or deprotected during the hydrogenolysis process, that is a hydrogen in presence of palladium charcoal, and then you will get the back carboxylic group RC double bond OH, as well as the side product obtained is this one, that is a toluene we are getting here, right? This is the structure of toluene, which is a side product obtained during this reaction. So these are the simple protection and the deprotection of this carboxylic group using the Dcci, or we can call it as a Dcc, NN dicyclohexyl carbodiamide. Now let us look at the mechanism, how the mechanism takes place here. First one, mechanism of protection. First one is a mechanism of protection. This one. Now first one, take down this Dcc, structure of the Dcc we can write here for mechanism point of view. Here N double bond C double bond N, then this cyclohexene ring. Now here is a acid, you can write for mechanism purpose C double bond O, then R. Now what is going to happen next here? Look, observe this structure carefully. This is a structure of Dcci, means NN dicyclohexyl carbodiamide. Now, and as we know that nitrogen atom containing as a lone pair, and it is capable of abstracting highly acidic proton from the acid, and then negative charge present on that oxygen atom, and you will be getting here the structure, this one cyclohexene, then N double bond C, then this double bond here H. Now this is a cyclohexene structure. Now look at here, nitrogen atom carries here 4 bonds, 1, 2, 3 and 4. Therefore positive charge comes on that nitrogen atom, and the another remaining thing, negative charge here C double bond O, and this one is a R, right? Now next, what is going to happen in the next case, this negative charge is going to attack on that carbon atom, and look at this positive charge get neutralized. See the mechanism RO carefully, and now what is going to happen next one, this structure as it is, this one, then N double bond C. Now here you can write, here I am writing O, then C double bond O R, and then NH, then this one, or this H you can write here above so that it looks nice. Now another, what is going to happen here, there is a benzyl alcohol, this one is called as a PHCH2OH, this is a benzyl alcohol, and this benzyl alcohol I am writing here HO, then this one PH, the lone pair which is present on that oxygen atom is going to attack on this carbonyl group. This carbonyl group, this electron revolving around it, and then this double bond shifted from here to here, and this double bond again shifted from here to nitrogen, and one H from here, it goes along with that nitrogen, and then the product obtained here will be this one. Let us look at here, R, I am writing R, then C double bond O, then O, this CH2 and PH. This is a protecting group, and the side product here you can get this one, this is a cyclohexene, then NH, then C double bond O, NH, and this cyclohexyl amine. Right, this is a side product obtained, but this is a protecting main product we have got here. Now let us move on to the next mechanism, that is a mechanism of the deprotection. Now mechanism of deprotection, this is a mechanism of the protection we have seen step by step. Observe these steps carefully, then you can understood how the mechanism takes place over here. Now is a mechanism of deprotection. Now is a mechanism of deprotection. How the deprotection can be done. Mechanism of deprotection here. Mechanism of deprotection, for that you consider, you take down this structure once again, R, C double bond O, then O, this CH2, and then PH. This is a protecting group. Now we are adding this H2 in presence of palladium charcoal, that is, this process is known as a hydrogenolysis, and hydrogenolysis I already explained at the beginning. Hydrogenolysis means it will cleave or it will fission the bond between benzylic side only Benzylic means this sp3 hybridization and the heteroatom, this bond is breaking by this process, whether it is a nitrogen atom or oxygen atom, it is nicely get cleaved, and we are getting here the product hydrogen and hydrogen. One goes along with that oxygen and one goes along with that methyl group, and we are getting resulting product RC double bond OH and plus this one CS3, then pH, that is a toluene we got here. So this is the mechanism of this D protection. So in this way we have learned the general mechanism of with the Dcci, how it takes place. Now let us look at as a example. With suitable example we are going to explain this point in a much better way. Let us see with the help of suitable example. Dcci used to protect the carboxylic group, the purpose to decrease the activity of the carboxylic group, because there is a problem of chemoselectivity raised due to the acidic proton, and that acidic proton interfere the base catalyzed reaction, and therefore we can use as this type of the protecting group, so that we can carry out the reaction at the other part of the organic molecule, and we will get the desired product. So to avoid the problem of chemoselectivity, we can use as such type of the protection and the deprotection of carboxylic group. And now let us look at here. Here is one of the suitable example. Let us see here NH2, then C double bond O, then this one C double bond O and the OH. Look, if you look at this structure carefully, what do you see over here? There are, if you observe this structure carefully, there are two functional groups. One is a amide functional group and second one is a acid functional group. And if you compare the reactivity between these two, acid group is a more reactive and this amide group is a less reactive one, and therefore we suppose if this compound is treated with BH3, is a well-known reducing reagent, what it will do, it can reduce this group, more reactive group, into the corresponding alcohol CH2, then this double bond remains as it is, CH2, then CH2 and then OH. But if you use as a same reagent and we want to remove that carbonyl group, this way CH2, then this CH2, 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 then 1, 2, 3 are there, then COOH, carboxylic group, we want there, so there is a need to remove this carbonyl group, means reduction of the amide group into the amino group, that you have to perform or you have to prepare or synthesize this compound. So how will you convert this group, keeping that carboxylic group as it is? What will be the suitable reagent so that you can convert amide group into as a amine? And for that purpose you must carry out the reaction of protection and the deprotection. And now let us look at here the protection, and as we know that we can protect as a more reactive group, let us see here, C double bond O, then NH2, this CH2, this CH2, then C double bond O, OH. This will be treated with DCCI in presence of pH CH2OH. What do you get? You are going to get here this NH2 as it is, then C double bond O, then this CH2, and then C double bond O, then CH2, and this one is a pH. This is what we did here. We protected the carboxylic group here by using the suitable reagent. We have used the reagent here NN dicyclohexyl carbodiamide in presence of the benzyl alcohol. It get protected easily, and now you can carry out the reaction. You treat this compound with BH3 in presence of THF, and as we know that THF means tetrahydrofuran. I think in the previous lecture I have drawn some something. I think structure is a tetrahydrofuran, has a structure is this one, tetrahydrofuran. This is the structure of tetrahydrofuran. In the previous lecture I think I have drawn structure something like this. This is a that is a pyron is there, so that is not the tetrahydro. So let us what we can call it as a clear the point tetrahydrofuran. This is a structure of tetrahydrofuran, and in a previous case if you observe, if you watch that a lecture carefully, then and then you come to know that. But here look at the structure of tetrahydrofuran is this one, and it is used as a solvent for the reaction. And what do you get? You are going to get here the structure, the product. You are going to get where to write this one. I am writing here this arrow showing here. So let us see here how this takes place here. NH2, then this CH2, then CH2, then double bond O, then O, this CH2 and the pH. And if it is converted this one, then you can treat with H2 palladium in presence of chalcone, that is the hydrogenolysis. And after the hydrogenolysis, what you are going to get? You will get the product NH2, then this one CH2, then double bond O and the OH. This is the product which we require. 1, 2, 3. So 1, 2, 3 CH2, COH. That is the thing we are going to get here. Now let us move on. Let us see the mechanism, how the mechanism takes place over here. We know the mechanism up to this. Let us see mechanism of the protection once again here. How the mechanism of this takes place. Let us see properly here. Now, the structure which example we are considering here, NH2, then this one C double bond O, then CH2, then C double bond O, OH, right? And that will be treated with DCC, means this is a DCCI. Here N double bond C double bond N, then this one. So what is going to happen? The lone pair which is present on that oxygen atom, which can abstract or which can pick up this proton or abstract this proton, and we are going to get here the product, this one NH2, then C double bond O, CH2, then CH2, C double bond O, O minus and plus this one N, here is a H, double bond C, double bond N and then cyclohexyl ring, right? Now the positive charge comes on it. Now what is happening next one, it is going to attack on this carbon atom and this positive charge get neutralized, so that you are going to get the product here NH2, then C double bond O, this CH2, then C double bond O, then O, we can write here this C, then double bond N, then this one, here also double bond, not double bond, here single bond nitrogen, then H, then we can draw this cyclohexene structure, right, like this, right? Now next one we are using here HO, then this pH lone pair which is present on the oxygen atom. Now what is going to happen, this is going to attack on this carbonyl group, this revolving around it and this forming as a double bond over there, and then this double bond and one hydrogen up from here is going there, and we are going to get the product, this one, sorry, here not, yes, very good. Now is a NH2, then here C double bond O, then CH2, then C double bond O, then CH2 and then pH, and side product as we know that this one NH C double bond O, this is the oxidizing reagent, get reduced over there and you are going to get this. This is the side product, don't think, but this is our main product. Now we are treating with that BH3, means that boron trifluoride, it has a MTP orbital. Now lone pair which is present on oxygen atom is going to move in this way, forming as a bond between this nitrogen and this carbon atom, and this double bond is now attacking on this empty orbital. We can show like this arrow, and then next one, what is going to happen here, double bond NH2, positive charge comes over there, then this one oxygen atom B, there is a boron, then H minus charge develop on that boron atom, and then this CH2, then double bond O, and then this one pH, right? And what do you get there? Now this hydride get transferred from here to here, and then that positive charge get neutralized, and you are going to get here this one NH2 lone pair as it is, then this one O, then here is a boron BH2 you can write here, and then this CH2 C double bond O, then O CH2 and this pH. Now one of the proton from here. Now what is going to happen, another hydride from here, one H transfer from here to here, this get cleaved, and we are going to get here this one NH2, then this CH2 double bond O, then this pH, right? And after that, what is going to happen here, then hydrogenolysis. As we know that the deprotection is to palladium in presence of charcoal. Mechanism we already seen. Here bond is going to break and finally you are going to get NH2, then this CH2, then this one CH2, C double bond O, then OH acid we are getting as a back here. So in this way we have learned how the mechanism takes place. With the suitable example we have seen this Dcci as the second one, and the third protecting group used for the carboxylic group that we will see the next lecture. Let us stop today here. Have a nice day. Thank you.